Hi guys, this is going to be a video, excuse me, on the revision of products going into grade 10, from grade 9 to grade 10. And this is something that you would have covered already, and the first sections of grade 10 involve a direct build on products. So it's very important that you do revise this section. So just a quick revision of the various nomenclature that we're going to be using. Well, first we need to know exactly what a term is, and terms in mathematics are separated by pluses and minuses. I know that's not a good definition, but it's a nice way to identify exactly what is a term and what is an expression. An expression is a combination of terms. So just to throw a few examples, if I have 2x, which means 2 times x, this is a single term. Whereas if I have 2x plus 3, well, there's a plus here. So therefore, this is a term, and that is a term. Therefore, this is an expression. This is a combination of terms. And expressions are named according to how many terms they have in their makeup. So, for example, if we have 2xy, just a standalone 2xy, this is what we would call a monomial. If we have 2xy plus 3z, well, there's two terms, 1 and 2. Therefore, it is known as a binomial. And just to do one more, if we add 2xy plus 3z minus 2, that's 1, 2, 3 terms, this would be known as a trinomial. The only thing that changes is the prefix before the word nomial. Mono means 1, bi means 2, tri means 3, etc., etc. So if we jump into a few examples of multiplying these binomials by one another. Remember, product means multiply in mathematics. So when we deal with the section of products, we are multiplying nomials by one another. So let's start with the basic one. Let's multiply a monomial by a binomial. Remember, mono means 1, bi means 2. So just a quick example, if we have an x and we multiply it by a binomial, x plus y, we use the law of distribution. Remember, we can't, I know BODMAS suggests that we should do the brackets first, but algebraically we can't. So we need to resort to another algebraic method, which is known as the method of distribution. And remember, products means multiplied. So everything is multiplied by one another. So x times x is x squared. And x times y is simply xy. If we move on to a binomial multiplied by another binomial, we would employ the method known as FOIL. I'm sure you guys have seen that before. FOIL is F-O-I-L. And FOIL simply stands for first, outer, inner, and last. So the first would be the x times the x, which would be x squared. The outer would be the outermost terms, which are the x and the 2, the positive 2. So x times 2 is 2x. Remember, you're multiplying these terms by one another. The inner terms are the plus y and the plus x, which would be xy. And the last would be 2y. There are no like terms in this expression, so that would be our final answer. Now we start getting towards the grade 10 part of this section of work, and that would be to multiply a binomial by a trinomial. And unfortunately, we can't use the method of FOIL anymore. And what I prefer to use, I call it everybody gets a turn. This is just the method that I use. If you have your own individual method, that's perfectly fine. So what I would do is I would take each of these terms and multiply it by each of these. So if I take the x first, I'm going to multiply the x by that term, and that term, and I'll do the same for the y. So if I do the x first, well, x times x squared is x cubed. X times 2xy would be 2x squared y, and x times y squared would be y squared. Okay, that's that one done. Now let's do this plus y. Well, y times x squared would be x squared y. I like to write it in alphabetical order. Y times 2xy would be 2xy squared. And y times y squared would be y cubed. Now, we just need to be careful. Do we have any like terms in this expression? Well, I see an x squared y over here. And I also see an x squared y. So this term and that term we'll be able to add those together. X cubed is a standalone term. Let's write this in the powers of descending order. It doesn't actually matter, but it just looks better if you write it in descending order. So the highest exponents always get written first. That's this one and that one. Okay, let's write the let's solve this. So 2x squared y and x squared y, this is like, adding apples. If you have two of these and you have one of these, that means that you have three of these. So that takes care of that and that. Plus y squared plus 2xy squared. Remember, x squared y and xy squared are not the same term, so please don't, confuse that. It's very easy to confuse. Some common mistakes that I've seen in students when it comes to products is that students forget that they are constantly multiplying. You're not using any other maths operation. You are only applying multiplication rules, and along with multiplication rules means that you need to revise the basic algebra rules of multiplication. So, any like terms, when you multiply these by one another, will result in a positive number. And, likewise, unlike terms will always result in a negative number. This set of rules needs to constantly be referred to when you are applying products, when you are performing products. And another mistake that I've seen students make is they forget to recognize common factors, like I was busy with in the previous example. And this is very easy to overlook. Remember I said that, x squared y and xy squared, these are not common factors. You can't simplify this. These are completely different terms. However, if we had, for argument's sake, a 3xy plus 2yx, this is easy to overlook. You might think to yourself, no, this is not a common term. But it is. It is. It is, because xy is the same as saying yx. So we could, simply simplify this to 5xy. Even if that's not written in alphabetical order for whatever reason. So just be on the lookout for things like that. And just lastly, when we are multiplying various polynomials by one another, you can think of it as, in the first example, mono is 1, bi is 2. 1 times 2 is equal to 2. In other words, you should get two terms out of this, 1 and 2. So we got two terms out of this. If we look at the binomial by the binomial, 2 times 2 is 4. 1, 2, 3, 4. A binomial by a trinomial, well, 2 times 3 is 6. 1, 2, 3, 4, 5, 6. Obviously, when we simplify it, we could end up with any number of expressions, but the base form for this answer will have 6 terms in it. Can you guess how much a try by a try will make? Well, I'll leave that one to you guys. I will be releasing more examples later on. Thanks for watching, guys.